both subtraction signs, so it doesn't matter which one goes with which because they're both going to be subtract. And we still have our Q. Then since I took something out, I have to put it back. So A plus 5B minus 6 times A plus 5B minus 7. Yes?
Does it matter that they're the same thing in both parentheses? Like, wouldn't that be something or no?
If they're both negatives?
No, like, because it's A plus 5B, and then the other one's A plus 5B too. Does that not mean?
No, they're all like that. This one's
Oh, are they really?
3x plus 4y, 3x plus 4y. That's the, yeah, that's the point. You're thinking, like if we're adding and subtracting polynomials. These are being multiplied by each other, so there's no like combined like terms. Okay, try another one. Number 8. Okay, for number 8, I want you to try x minus 7 quantity squared minus 13 times x minus 7. Oh, sorry. X minus 7 quantity squared minus 13 times x minus 7 plus 36. So again, I'm going to substitute out the x minus 7, substitute in for a q. There is no GCF because there's nothing in front of this. And 13 and 36 wouldn't have a GCF either. So this is q squared minus 13q plus 36. I'm going to figure out what multiplies to 36, adds to negative 13, so we could have 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. These are adding together. So if you add those together, we've got 37, 20, 15, 13, or 12. We want the 4 and 9. When you break these apart, it's addition at the end, so both are the same as the middle, so 2 negatives inside. 4 and 9, doesn't matter which one goes where because they're both negative. So q minus 4 and q minus 9. Then plug back in x minus 7 minus 4 and x minus 7 minus 9. There's nothing being distributed through, so you can drop the internal parentheses. Now, am I done?
No.
No, because there are still like terms. So you do have to combine those like terms. So x minus 11 and x minus 16 are your answers here.
Wait, it's not done with x minus 16. You got one more, right?
X minus 16 does not factor. You're thinking x squared minus 16.
Oh, yeah, that's right.
Okay, now, a couple of challenge problems. These are going to be more the type that you will see on your honors test, on the honors test, excuse me. Okay, so a couple of challenge problems. I would like you to factor completely 81 minus 5 plus x quantity squared. 81 minus 5 plus x quantity squared. Now, this is a little bit backwards from the ones we've been doing, but if there's a quantity, you're still going to take it out. Okay, so we're still going to replace it with the q. So replace it with q. Then that gives you 81 minus q squared. There is no GCF here. And there's two terms, so it has to be difference of squares. So one gets a positive, one gets a negative. 81 breaks down to 9 and 9. Q squared breaks into q and q. When you substitute this back in, that's 9 plus 5 plus x and 9 minus 5 plus x. This is another reason that it's important to have the internal parentheses, because when you drop them, this first one, it's still 9 plus 5 plus x. But the second one, what happens? The negative has to be distributed. So if you didn't have the internal parentheses, you would have only distributed it to the first one and not to the x. And then you'd get it wrong. Okay? So make sure you have those internal parentheses. I know a lot of you do not want to have to show that step, but it is important because sometimes you do have to distribute things through. Then combine your like terms, so 16 plus x multiplied by 4 minus x. That's the answer there. Okay, so make sure you keep those internal parentheses. 14. I'm sorry. Thank you. Okay, one more. Okay, last challenge problem. And I sent your test off to be copied this morning, so I happen to know that there is one very, very similar to this exact problem on your test. 2m squared times m squared minus 9 quantity m squared minus 9 plus m times quantity m squared minus 9 plus 9 minus m squared. Lots of m's. Oh, you'll live.
Oh my goodness gracious. So,
Now,
that looks like
let's think about this. Okay, stop. Enough. Okay, is this a quantity problem? No, this is not a quantity problem because it looks like it because it has the parentheses. But remember, the quantity problems have parentheses squared. What else does this kind of resemble? This resembles grouping, right?
yeah,
But these are a group. Is there a group back here?
No.
you added to the other.
There needs to be, right. Maddie, what do I have to do? Flip this, okay? We want it to be just like m squared minus 9. If I rewrote this, this would be negative m squared plus 9. So Maddie's right. I can factor out a negative, and then this would be m squared minus 9, just like your other parentheses. So bring down the others. Bring down the others exactly the way that they are. Now I can group. So that's one group. So I have a group of m squared minus 9. And my other group is 2m squared plus m minus what? A 1. There is a 1 there. So minus 1. Now, am I done factoring?
No, the front.
Not quite. This one breaks down to be m plus 3, m minus 3. And what happens here? This is leading coefficient trinomials. So this one breaks down to 2m and m. This is numbers in front, trinomials. So you know this has to be 2 times 1 and 1 times 1. 1 and 1. Then you have to check this. 1m, 2m's. I want it to be positive inside. I know I have to have 1 positive, 1 negative. So if I want it to be positive 1, the bigger one goes with the positive. First one goes with the negative. So minus plus. That's your answer.
Okay.
M plus 3 times m minus 3, 2m minus 1, and m plus 1.